In section 7.3, we'll be talking about separable equations. The title of this is called Separation of Variables, and that's exactly what we're going to be doing. Now let's say if I had a differential equation, and I had y prime, which is equal to 2x divided by y. And now what I want to do is I'm going to multiply both sides by y, and I'm going to get y times y prime, which is equal to 2x. So in the separation of variables, what I want to do is, just like I can do anything on both sides of the equations, I can take the integral on both sides. So I'm going to integrate the left side, which is y times y prime dx, which is equal to the integral of 2x dx. Now then we have to change this y prime dx to be dy, so we have all y's on one side and then all x's on the other side. Now, this is one way that you can do that, but I would recommend doing it this way. Now, instead of writing y prime, we can write y prime as dy over dx. So we'd have y times dy over dx, which is equal to 2x. Now, if we multiply both sides by dx, we're going to get y dy, which is equal to 2x dx. And then from here, we can then integrate both sides. So we're going to integrate y dy, which is equal to the integral of 2x dx. So when we integrate the left side, we're going to get 1/2 y squared, which is equal to the integral of 2x dx, which is 2 over 2x squared plus c1. Now the reason why I'm writing c1 is because eventually we're going to want to write it as c. And again, that's going to be a constant. So if we want to eliminate the denominator, we can multiply every term by 2. So we're going to get y squared, which is equal to 2x squared plus 2c1. And then if we subtract the 2x squared to both sides, and then we would let c equal to c1, and then there would be our result. So when you're separating the derivatives, or dx and dy, that is an example of separation of variables. Let's take a look at another example. Okay, let's say if I had y prime, which is equal to x times 1 plus y. So we're going to rewrite y prime to be dy over dx, which is equal to x times 1 plus y. And now we're going to multiply both sides so that we have all the y's on one side and all the x's on the other side. So you're going to have to divide both sides by 1 plus y. So you're going to have dy divided by 1 plus y. And you're going to multiply both sides by dx, so it's going to be equal to x dx. And then we're going to rewrite this fraction. So we have 1 over 1 plus y dy equals x dx. And now that we separated the variables, now we're going to take the integral of both sides. So we're going to integrate 1 over x plus y dy, which is equal to the integral of x dx. So we're going to get the natural log of 1 plus y equals 1/2 x squared plus c1. Okay, now in this step, we can use our properties of logarithms. So when we have a logarithm of a variable or argument, whatever you want to call it, and it's equal to this, we can rewrite this as a base of e. So the base of e, this is the exponent of that base e, which is going to equal 1 plus y. So it's going to be e to the 1/2 x squared plus c1, which is equal to 1 plus y. Now we're going to start using more of our algebra. So over here, since this is e to an exponent plus another exponent, we're going to use properties of exponents with the same base. So we're going to separate this using multiplication. So you're going to have e to the 1/2 x squared times e to the c1. And so now, since we know e to the c1, those are both going to be constants. So because that's both a constant, we can then let c equal e to the c1. So we're going to have c times e to the 1/2 x squared is equal to 1 plus y. And then now we're going to solve for y. So we're going to subtract 1 to both sides, and we get y, which is equal to c times e to the 1/2 x squared minus 1.